Hi everyone, how you all are doing? So today I'm back with another video and we are going to talk about CIDR, subnets and IP addresses. Well, the reason for creating this video is I have gone through a lot of websites, YouTube videos and reference material, and I realized that we all are told how to use CIDR blocks, but we are not told why this naming system exists. So as an engineer, it's our responsibility to dig in deep and try to understand why this thing happened and what is the purpose of it, why it was created, and what were the problems faced while choosing certain way of doing things, right? So in this video, I'm going to talk about the very fundamentals, and the purpose here is to understand CIDR blocks and not only to use it, but also to figure out certain things which are usually not told while creating CIDR blocks. Now, as a DevOps engineer, we have to create VPC, we have to allot IP addresses to people, we have to do a lot of things with IP addresses because of various clusters running, various Dockers running. But to choose the best, we have to understand how this works. All right. So this is the ideal IP address we all see, right? 92.168.1.10 oblique or /24. Now, what is this? Now you have to understand that this is an IPv4 addresses. There are two ways of naming or giving names to the IP addresses. This is IPv4 and IPv6. IPv6 is little advanced and it will take a lot of time to switch to IPv6, right? It is in the process of getting changed. Along with IPv4, we use IPv6, but IPv4 is nowadays existing, usable, and we have to reuse certain IP addresses. But to make sure things don't clash, we have to create subnets. We have to adjust our naming system in such a way that if two devices in the whole world are having the same IP addresses, they are not conflicting each other, right? Although numeric system is so vast that we can definitely pursue creating a lot of larger numbers to create IP addresses, but this is very irrelevant. This is going to require a lot of different infrastructure. A defined nomenclature will help us to manage things better. So if we check on our, if we can see that total number of unique addresses that we can give with IP addresses with using IPv4 is only this much, which is not even for one country. As we all know, even for one household there are 10 different unique devices, and each device have a different IP address. So it is practically impossible to give the whole world the same IP addresses repeatedly. So there was a concept introduced called subnets, right? So for example, there are two people with the same name, their surname may be different, and that is the unique identifier, right? If their surname is same, their home address might be different. If their home addresses are same, which is of course not possible, right? A person who is having the same name and same full name and same address, probably different DNA or something, some unique identifier. Okay, so for this also we require a unique identifier, and we introduce the concept of subnets. But before subnets, what happened? There was a class-based subdivision that was introduced. Now let me go back to the presentation once again. We'll come back to this later. Okay, so yeah, so we were talking about this, and yeah, this is an IPv4 address. It has 4 parts, that is octets. Now by octets, we all understand we're talking about 8 numbers, number 8, and by 8 I mean 8 parts. Okay, 8 binary parts. Each part ranges from 0 to 255. Each part is 8 bits, total of 32 bits. So this is 8, this is 8, this is 8 bits, this is 8 bits, and this is also 8 bits. We're not going to talk about this right now, but we are going to talk about the base IP. This is called the base IP, right, of IPv4. Moving ahead, there was a class naming system. We are not going to dig in deep because nowadays it is not required. There was a concept of giving A class, B class, C class. But as I told you, the octets is divided like this. So the base IP has four set of octets, and now the slash number is tell us how many bits are for the network. Now forget about this, okay? Right now, since long we were using this, and this is limited, as we all know. If we give only this IP address to a certain device, we all know there can be a breach of security. We can easily just randomly hack that device. Maybe we can also reach out and tap the address ID and various other things, right? Now /24 is an additional subnet that is added, which gives an opportunity to this IP address to create more IP addresses. Why this is done? Now you all will ask me why this is done. We can elaborate IPv4, we can maybe switch to IPv6, and we can do a lot of things. But my dear friends, the reality is when things are infinite, things are growing in a linear manner or exponential manner, it becomes very difficult to manage things, right? So if you are working in a company, there is an concept of intranet, there is a concept of private network, right? In that scenario, sometimes network engineers have to tap in the security, check the crowd, the consistency, the packages, where are they coming from, the kind of security they can apply, the firewall, and various other configurations. So for management, for security, for organization, we need to keep hold of how IP addresses are created, how IP addresses are distributed, and how IP addresses are named. Okay, so that we can tap in the information easily. All right, so as I said, we need for organization, we need for grouping, we need for efficient allocation. And as a DevOps engineer, you might be already doing these things, right? Okay, so going ahead, what does /24 mean? Now coming back to this IP address with a subnet of 24, what is this? Okay, so this means, so we all know there is one portion which has 8 bits, right? Now this is just an example. 24 is just an example. There is another section that is added, like a tail that is added to this device, which means 24 bits are for network. Remaining 8 bits are for host and devices. Now what are 8 we are talking about? We all know that this section has 8 bits. 8 bits, if converted to numeric system, it is 32. So 24 minus 32 is equal to 8. So if a numeric system, or if an IP address number is showing this IP address and /24, that means this space is allocated for the particular network. We all have 8 free bits we can allot to the host or the devices. So it is a set of 24 bits that is being assigned to the network, and 8 bits is being assigned to the host. Since 8 bits are left, 2 to the power 8 is equal to 256 IP addresses. Now, why 2 to the power 8? Well, in the concept of bits, if we are talking, there are 2 possibilities at each position, 1 or 0. That is the reason we are using 2 to the power 8, which is equivalent to 256 IP addresses. And this means that if this is the subnet, we can create 256 unique IP addresses in this particular network. All right. Now, so this is just an example. Before coming to the example, let me show you the CIDR block calculation calculator. All right. Okay. So this is very famous. This is being used in various industries, and if you can see that for each, this is the base IP address and this is the slash part. Now if I add 500 here, I cannot. Why? Because it's the maximum number is 255, which means this can be only 255. In an octet, the maximum number is 255. Okay, so for example, for every block, as you can see here, right, it's the maximum number is 255. All right, I'm trying to write as many as possible, but this is set in such a way that the maximum number is reaching to 255. Now you have to understand that before going to that, I will create a simple IP address one. So if you can see that I have added 192.30.1.75/24. Now what is this? Maybe let me put 24 to 16. Okay, perfect. All right, so if you can see, this is 255.255.00 is the Netmask. CIDR base IP. Now this is the base IP from where we should ideally start numbering our devices. So if I add 14, if I add 67, whatever I want to do. So this is the base IP, this is the broadcast IP. Now broadcast IP is always 255. The last IP is where is what we call broadcast IP. This IP address willingly send broadcast messages to all the other devices connected in the same network. Count is the number of devices we can connect under this IP setting. Okay. Now first usable IP is this, and the last one is this. Now if we subtract this from this, we will get the count of this. So I hope you understand what CIDR calculator helps doing, right? Okay, so if we increase the number, for example 32, if you see 32, now 32 minus 32 is equal to 0, and 2 to the power 0 is equal to 1. So we are only left with one device. So first and the last IP addresses are the same. So it's an important skill. It's a hidden important skill. It comes with practice, and you can definitely do it. Sometimes people create these many counts of devices while they are using just handful devices. So it's a waste of IP addresses, right? Okay, so this is a reason CIDR calculator is used, to understand the possibility. Now in a company which can grow to 65,000 headcounts or maybe lesser, they definitely create this. But if it is a small startup, they might just create, this is too less, right? 4 count is too less. Okay, they might create 28, maybe, this IP address. Okay, so this is where we focus on. Now as you can see, I have done a little calculation here. So this is for single device. Now these questions I was very much curious about, so I digged in a little deeper. I used ChatGPT and various other generative AI tools to question. Now we all know that CIDR defines how IP addresses are grouped, but the slash number shows how many bits are reserved for the network and are available for hosts. Okay, public IP are assigned by our IP address. So wherever you are sitting, you are connected by a network. It could be a public network or a private network. By private network, I mean your home network or maybe a library. So it is, both of these are managed by ISPs, internet service providers, and they act as a single entry point for your whole network, while private IPs are internal. Okay, so whenever you want to connect with me via remote connection, I will only be able to see your public IP addresses, not your private, which is on your device. Okay, and same with you. Okay, so we have to pass through our public IP address to talk to the whole internet world, right? Private IP addresses are created within, under the public IP address to keep things segregated, consolidated, and clustered so that it can be tracked easily. CIDR.xyz that we check help us calculate subnet ranges, and each subnet breaks down IP addresses logically. SSH connects typically, so CIDR we understood very well. Now SSH connections, it's very crucial. SSH connections typically go through our public IP address and then route inside via private IP address. So whenever we do SSH, don't think that we are directly dealing with the private IP address. We are definitely interacting with the public IP address of that particular server to interact with the EC2 instance we are creating, for example. Okay. Now, there was one naughty question that I had. I was asking, where do hackers attack? Well, they can't reach our private IP addresses. They can only reach our public IP addresses since those are exposed, but threats can be spread internally if not secure. Now, for example, we both are, you and I both are under same public IP address. We both have dedicated private IP addresses. If I am the person who want to hack your account, or I want to spread the malware, I can very easily, download it. And if you are in my same network, you are also in danger. Okay. So if we both have common public IP address, the other users can be in a vulnerable state as well, because we are in the same network. Okay. So as a network, or coming to the next point, as a network or network admin, so as a DevOps or network admin, you can use tools like Ansible or automate software deployment access across IP address. Now, we all know what Ansible does. It creates a playbook and all, and manage many devices in the same network. The private IP structure is independent of public IP address. You can choose for it for a logical organization. Definitely, we can. Now, even if I'm sitting at my home and I'm using my private IP address, I can use my public IP address to create various private IP address, or I can manage subnets. Naming private IP should follow a logical, consistent pattern, but you have flexibility. Just avoid overlap. Well, there is no such pattern defined, but some IP addresses are reserved for private range and are defined by RFC 1918. If you read it, it's very interesting, and it's not random, and it can give a kind of standard while naming a private IP addresses within an organization. So if you are doing it on a small scale, it doesn't matter actually, but if you are doing on a larger scale, setting up a standard in your company so that when your company increases, you grows, so that when your company grows, you follow the same pattern. So that's it for today. I hope you understood CIDR concept and why we use it. It is very fundamental, I know, but sometimes we are not able to give the answers to the most fundamental things because we are told how to do it. We are not told why to do it. Okay. So keep learning, keep exploring, and keep your mind curious. Thank you for watching the complete video. Please like and subscribe.